Ever wondered what that weird port under your steering wheel is? That's your car's OBD2, and in this video, we'll explore what it is, its standardized services, various emission monitors, diagnostic procedure, and OBD scan tool technologies. So, please make sure you subscribe to this tiny channel before diving in. Onboard Diagnostics, or OBD, is a built-in vehicle self-diagnostic and reporting system. It's designed to detect malfunctions that could increase tailpipe emissions. Test is made to identify deterioration, manufacturing defects, and tampering with emission control systems. OBD systems typically run a computer test while the vehicle is driven. OBD help ensure that vehicles comply with federal emission standards. It can also monitor non-emission related systems to detect problems early. It can help technicians diagnose and repair problems more quickly and efficiently. They also help with fuel economy. We are talking about OBD2, so it is natural for you to ask, what about OBD1? It was a pioneer in the fight for cleaner air. It is aimed to control vehicle emissions by requiring annual tests and denying registration to cars that failed. It was a significant improvement over the old tailpipe test because it was comprehensive. OBD1 could monitor all emission-related components individually, not just the exhaust itself. Testing was quicker and less expensive than tailpipe tests. It was precise. OBD1 identified the exact fault, allowing for targeted repairs. It even detected evaporative emissions, vapors that escape from your fuel tank and system. Plus, it could sniff out cold start problems. But OBD1 lacks standardization, as each manufacturer had their own system. Their own data communication system between the cars and diagnostic tools. Their own data port location, making it a treasure hunt to find where to plug in. Their own definitions for diagnostic trouble codes, making the mechanic's job extremely difficult. And their own diagnostic procedures, adding another layer of complexity. This lack of uniformity made OBD1 unsuccessful, which brought the birth of OBD2. OBD2, the successor to OBD1, arrived in the mid-1990s and brought much-needed order to the car diagnostic system. OBD2 became mandatory for all light-duty vehicles by 1996, and by 2004, it covered medium-duty vehicles as well. This standardization is what makes OBD2 so powerful. Here's how it works: a set of rules, established by the Society of Automotive Engineers, or SAE, dictates everything from when the check engine light turns on to how a scan tool talks to your car. SAE Standard J2012 clearly defines the conditions that trigger the check engine light. This ensures consistency across manufacturers, so you're not left guessing what a blinking light might mean. Diagnostic trouble codes, or DTCs, again, thanks to SAE J2012, these codes have a universal language. A code like P0171 means the same thing on a Ford as it does on a Toyota, making it easier to pinpoint the problem. Scan tools. SAE J1962 established a common protocol for how OBD2-equipped vehicles communicate with scan tools. This allows any scan tool to speak the car's language and retrieve valuable diagnostic information. Services and modes. SAE J1979 defines a variety of diagnostic services or modes available through OBD2. Freeze frame. This feature, also defined by SAE standards, captures a snapshot of the engine's operating conditions when a malfunction occurs. This helps technicians diagnose problems that may not be present during a normal scan. By creating these common standards, OBD2 transformed car diagnostics from a confusing mess into a clear and efficient system. OBD2 services, or modes. There are 10 main ones outlined in the latest OBD2 standard. Mode 1. Show current data. This provides real-time information on engine performance, speed, throttle position, and other vital signs. Mode 2. Show freeze frame data. This captures a snapshot of the car's condition when a problem first occurred, helping pinpoint the issue. Mode 3. Show store diagnostic trouble codes, or DTCs. These are the fault codes stored by the car's computer. Mode 4. Clear diagnostic trouble codes and stored values. Once the problem is fixed, this service resets the computer. Mode 5 and 6. Test results for specific components. These services are like targeted tests, focusing on areas like oxygen sensors or emission systems. Mode 7. show pending diagnostic trouble codes. This acts as an early warning system, identifying issues that haven't triggered the check engine light yet. Mode 8. Control operation of onboard system. It allows controlling certain systems for further diagnosis. Mode 9. Request vehicle information. This retrieves general car details like VIN number, model year, or software used. Mode 10. Permanent diagnostic trouble codes. These indicates problems that haven't been resolved yet. It's important to note that car manufacturers aren't required to support all services, and some may even offer additional ones. OBD to parameter IDs. OBD2 IDs are like specific requests you can send to onboard computer. Each PID code asks for a particular piece of information, such as engine RPM, coolant temperature, or even fuel pressure. Here is an example of service 1 request IDs and corresponding responses. Like so, there are similar parameter IDs for all services. OBD2 monitors. Your car runs up to 11 different checks on every source of emission to make sure it is meeting emission regulation. There are 2 types of monitors: non-continuous monitors. These monitors run only when vehicle conditions are appropriate for testing. This is called readiness. Here are continuous OBD2 monitors. The catalytic converter. The system checks the difference between sensors before and after the converter to see how well it's working. The evaporative system. The car checks for any escaping gas, hydrocarbon vapor. The oxygen sensors or O2 sensors monitor. These sensors monitor how much oxygen is left in the exhaust. The system checks the voltage output of the sensors to see the amplitude threshold and switching frequency for lean and rich mixture. The exhaust gas recirculation or EGR monitor. The car checks the flow rate of the exhaust gas and makes sure the related sensors are functioning correctly. The secondary air system. This system helps the engine run cleaner during cold starts. The car checks the air pump and the O2 sensors to make sure everything is working together smoothly. The air conditioning system. If your car uses Freon 12 refrigerant, the system checks for leaks in the AC system. Your car's computer is constantly monitoring some key systems for problems with emissions. These are called continuous monitors. Engine misfire. If your engine is misfiring, the computer can pinpoint the exact cylinder causing the trouble by monitoring the crankshaft speed. The fuel system is also continuously monitored. By looking at sensors like the manifold absolute pressure or MAP and delta pressure feedback electronic or DPFE, the computer can identify if the engine is running too lean or too rich. Comprehensive components monitor. Input and output electronics are tested for functionality and rationality. There are a couple of reasons why your car's OBD system might not be ready for an emissions test. The first is if the trouble codes have been recently erased. Erasing these code resets the system, and hence is required to go through readiness drive cycle to be tested. Another reason is if the computer or PCM in your car has been disconnected from the battery. This also disrupts the system's self-checks. The good news is, the system can become ready again. It just needs to go through a specific driving pattern called a drive cycle. Here's the catch: every car manufacturer has their own drive cycle. So, consult your manual for your specific make and model. This diagnostic procedure is like a doctor's checkup for your vehicle. The system first waits for the right conditions to run its tests, which we call readiness. Once the conditions are right, the car's computer checks all the incoming signals from all network of sensors. It then compares these readings to OBD2 emissions criteria and checks the functionality and rationality of all emission components. If there's a problem, the computer notifies you something's wrong in a few ways. Malfunction indicator lamp illumination. This turns on the check engine light on your dashboard. Fault code storage. The computer remembers the problem for future reference. Freeze frame data. It takes a snapshot of the engine conditions at the time the problem occurred, helping mechanics diagnose the issue. The malfunction indicator lamp, or MIL, is a dashboard warning light that is connected to the OBD system. If there's a serious problem, like a misfire that could damage the engine, the MIL will start flashing. This is a sign to pull over and get your car checked out right away. Usually, though, the MIL will just stay constantly lit. This means there's some kind of issue, but it might not be super critical. The car's computer is pretty smart. If the problem goes away and doesn't come back on 3 trips in a row, the MIL will turn itself off. It might have been a minor glitch, kind of like a hiccup. Starting the car can sometimes trigger the mill for a second, but that's normal too. Diagnostic trouble codes. These codes are 5 letters and numbers long, each part giving us a clue about the problem. The first letter tells us which system in your car is having an issue. P stands for powertrain, which includes the engine, transmission, and other parts up to your car's tire. C means chassis, which covers things like steering, suspension, and brakes. B is for body, including parts like airbags, air conditioning, and everything inside the passenger compartment. U indicates a problem with the network or how different computer systems in your car are talking to each other. The second character is a number that tells us if the code is a general code defined by SAE or specific to a certain car manufacturer. The third character is another number that gives us a closer look at which part of the system is having trouble. There are 8 categories, like fuel system, ignition, or transmission. The last 2 characters are numbers that pinpoint the exact problem. For example, a code like P0782 means there's a problem with the transmission. It's a general code, and there's a malfunction when shifting from second to third gear. OBD to communication protocols. Thanks to these protocols, a single scan tool can be used on almost any OBD to car. Here are some of the most common protocols used. SAEJ185OPWM. This is often used in Ford vehicles. SAEJ185OVPW. This one is commonly found in General Motors cars. ISO 9141-2. This protocol is used in Chrysler, European, and some Asian vehicles. ISO 9141-2, KWP-2000, commonly known for Chrysler, European, or Asian vehicle. ISO 15765 CAN. These are 2-wire recent methods protocol and has been mandatory for all cars sold in the US since 2008. The OBD to connector, also known as the Data Link Connector or DLC for short, is located underneath the dashboard, near the steering wheel area. There are 2 types of DLC. The OBD to connector has 16 pins, and each pin has a specific purpose defined by a standard called SAEJ1962. 7 of the pins are OBD2 specific, while the remaining 9 are reserved for the manufacturer discretionary. For example, Pin 1 is non-standard and depends on the vehicle's manufacturer. It is not required for normal communication. Pin 2 is bus-positive pin of the protocol. It uses the variable pulse width protocol and is typically found in General Motors vehicles. Pin 3 is non-standard and depends on the vehicle's manufacturer. It is not required for normal communication. Pin 16 connects to the vehicle's battery to power scan tools. You can use a simple or professional OBD to scan tool to retrieve the DTCs. Plug these tools into the vehicle's OBD to port. Once connected, power on the ignition without starting the engine and follow the scan tool's instructions to read the DTCs. OBD to scan tools come in various communication options to connect with your device, offering flexibility for both mobile and computer use. These options include traditional serial connections RS-232, the more common USB connection, as well as wireless options like Bluetooth and Wi-Fi. Simple code readers. These are basic tools that display the DTCs and sometimes a brief generic description. They are affordable and easy to use, and there are also professional scan tools. These offer more advanced features like live data monitoring like sensor readings, freeze frame data, DTC definitions with more detailed explanations, and ability to clear DTCs after repairs. I will put links to the Amazon page of top 5 wired and Bluetooth scanner if you need to grab one for yourself. Please subscribe to the channel if you have learned something valuable from this presentation.